Okay, in this video we are going to be solving this problem. It's got two parts. We are given dy dx minus y tan of x equals cosine of x. We want to find the second degree Maclaurin series or polynomial if y equals negative pi over 2 when x equals 0. This is very much a Calc BC topic. You better know how to do this. And then part B would be an extension for Calc BC. Solve the differential equation if y equals 0 when x equals pi. This is not going to involve a Calc BC technique, which is why you wouldn't have to do this particular problem, but I do want to make it clear, you will definitely have to solve differential equations, just not this type of equation. So you would expect like a separable differential equation, for example, maybe something where you need partial fractions, something like that. But let's do part A because everybody's got to be able to do that, and then I will also do part B just to show you the technique. So we're looking for the second degree Maclaurin series if y equals negative pi over 2 when x is 0. So the first thing that I'm going to do is I'm actually going to rearrange our given to just solve for dy dx. So dy dx is y tan of x plus cosine of x. So I've moved over y tan of x. And then what I'm going to do is evaluate this at the ordered pair 0, negative pi over 2. So make sure you have those in the right order, right? X is 0, y is negative pi over 2. Now we're going to plug in. So y is negative pi over 2, and then the tangent of 0 is 0. The cosine of 0 is 1. So we have negative pi over 2 times 0, gone, plus 1 is equal to 1. So that's the value of the derivative. Now we need to find the second derivative, which is going to involve the product rule and a lot of chain rule. So let's see if we can do that. So for y times tan of x, we have to find the derivative using the product rule. So it's going to be first derivative of the second, and then plus second, which is tan of x, derivative of the first. So it's the derivative of y is dy dx. Now the key thing here is we know the value of dy dx at the ordered pair is 1 because we just found that. So when we go to sub in, we don't have to sub the expression for dy dx. We can just sub the value of 1. And then don't forget we need the derivative of cosine, which is negative sine. Okay, we are going to evaluate this at our ordered pair, keeping in mind that at this ordered pair, we know dy dx is 1. So this is going to give us negative pi over 2 times 1 plus 0 times 1, because the tan is 0, 0. And then minus the sine of 0. So don't get confused there. Like negative pi over 2 is an angle, but it's not what you're subbing in. You're subbing in 0. So the sine of 0 is 0. So overall, this just gives us negative pi over 2. So now we're ready to write our series, or this problem calls it a series. I tend to call them polynomials. So our Maclaurin polynomial is going to be, I'm going to call it y and say y is approximately. So our value at 0, right? So that's where we start out. So that's negative pi over 2. And then plus the derivative at 0 over 1 factorial x minus 0 to the first. So I tend to write that out. Like, I don't think everyone does. I just like to keep in mind the pattern that we're going to follow. Also, the first degree Maclaurin in this case, or the first degree Taylor polynomial, is going to be the tangent line. So if you can write tangent lines, you walked in knowing how to write the first degree Taylor polynomial. Now we just have to add in the second degree term. So it's going to be the second derivative over 2 factorial x minus 0 to the second. So our second derivative was negative pi over 2 over 2 factorial, and then x minus 0 to the second. You can, generally speaking, just leave this the way it is. I cleaned it up for like no apparent reason, and I ended up with this. That's the answer to part A. This is very much a BC question. You have to know how to do this. What I also want to do is show you how you can use your TI-Nspire to solve this problem in the event that you're allowed to do that. What I'm going to do, I guess, is just solve the differential equation. So I'm going to press menu and then option 4 for calculus. I always use the arrow keys. I just press up a couple times. You have to get to D, differential equation solver. So the CX2 has this option. The CAS, you need to have a CAS to do this at all, but the CX2 has this option where this little wizard pops up. If you have a CX1 or a pre-CX, maybe the CX1 also has it. If you have before that, it doesn't have this. And just wait until the end and you'll see what you would need to type in. So here's what we're going to type in. Y. Then we need prime, which is in the question mark. Just go here. Y prime equals y times the tangent of x, and then plus cosine of x. And then I'm going to press tab. The independent variable is x, the dependent is y, and then we need to put in a condition. So notice it's telling you an example of what your differential equation would look like, an example of what your condition should look like. So y of 0 is negative pi over 2. You can also use the pi key. So if I delete that and go down here to pi and press enter, I'm going to press enter. If you didn't have a wizard pop up, this is what you need to type in. And it's kind of annoying, but what are you going to do? So I'm going to solve this, and it's actually like we'll know the solution to the differential equation. So now what I'm going to do is I'm going to use this to find the value of the derivative and the value of the second derivative. So I will use the templates. So here, derivative, get out of the way. With respect to x of, let's go up and get the right-hand side of this. Whoops, wrong place. There we go. I'm using control, copy and paste, cut, copy and paste, control X, control V, that sort of thing. So I want this when x is equal to 0, right? So that was such that x equals 0. And then I want the second derivative. So again, like this. It's actually kind of better if you start with the second derivative, because you can change the order of the derivative, like that little exponent looking thing, from a 2 to a 1, and then x equals 0. So we get this. So that's where my values are coming from. But let's say that I actually already have the function. I can just have the calculator find the Taylor polynomial. So if I go to calculus, I'm going to press up again, get to C, and we want Taylor polynomial, right? So I want a Taylor polynomial of this, comma, x is the variable, and I want the second degree. And it just spits it out for us, which is kind of amazing, right? So that's a pretty good deal. I'm now going to take a look at part B and just solve it for you, just to show you a really interesting technique. So this type of differential equation, not required for the Calc BC exam. However, it does use something called an integrating factor. An integrating factor in our case is going to be e to the integral of negative tan of x. So I know that because of the form of the differential equation. It's like dy dx plus y times some function of x. When you see that, you can use the integrating factor. I'm going to evaluate this. The integral of negative tan of x is the natural log of the absolute value of cosine of x. Generally speaking, you just leave out the absolute value on this, but that's like conventionally you just kind of do. So we have this, and then e to the natural log of blah is just whatever blah is, so we just get cosine. Now what I'm going to do is I'm going to multiply both sides of my differential equation by the integrating factor. So I'm going to end up with cosine of x dy dx, and then minus y times tangent is sine over cosine. So if I multiply that by cosine, the cosines cancel, so I just get minus y sine of x. And then on the right-hand side, I'm going to get cosine squared, right? Because I'm multiplying by cosine. Now, here's how this works. You make the observation that the left-hand side is the derivative of y times the integrating factor. So y times cosine of x. Try it out. Find the derivative of y times cosine of x using the product rule. You will get what we have there. So this is the derivative with respect to x of y times cosine of x. To integrate cosine squared, I always use the double angle formula. So I'm going to switch cosine squared of x into 1 plus cosine of 2x over 2. So I have this. If I integrate the left-hand side, because it is the derivative of y times cosine of x, integrating that will just give me y times cosine of x. And then I need to integrate the right-hand side. But this, if you've done enough problems with integrating powers of trig, you've integrated this probably a ton of times. It comes up a lot. So this is going to give us y times cosine of x, and then we'll have 1/2 x, and then plus 1/4 sine of 2x, and then plus c. So we do need to solve for c. Our ordered pair in this case is pi comma 0. So if I plug in pi and I plug in 0, plugging in 0 for y makes the left-hand side just 0. And then we're plugging in pi here. The sine of 2 pi is 0, which means we just get 0 equals pi over 2 plus c. And then that means that c is negative pi over 2. And then we have to solve for y, so I'm just going to divide by cosine of x, and it's not going to look really pretty. but this is what we get when we see, I should say. Now I'm going to divide by cosine of x and get that. Okay, I also want to show you how to use your calculator to solve this differential equation in part B, but I mean, I kind of already did it in part A, so I will go a little quicker maybe. So I'm going to put a new problem, that's doc 4.1, and calculator, and we're going to do menu, down to calculus, up to differential equation solver, and our differential equation is y prime equals y to, actually you don't need to rearrange this, I think. Y prime minus y times, let's find out, tan of x equals cosine of x. X is independent, y is dependent. For this particular problem, it is that y of pi is equal to 0. Okay, press enter, and I press enter, and it solves it for us. Now the question becomes like, is this the same as what I got when I solved it? So what I would do is, this won't always work because of domain-based issues, but I'm going to type in what I have. X over 2 plus 1/4 sine of 2x minus pi over 2 over cosine of x. If you get like false or it just returns what you typed in, what I then would do is either graph both of them, or I would just sub values into both of them and see if they give the same result, because domains are a little tricky and the calculator doesn't like dealing with them. But that's how I would do this on the calculator. So that's the problem. You're not required to do this for Calc BC, but it's kind of neat and eye-opening to see, you know, extra things. So that's our problem. I hope this was helpful, and good luck.